Hello, people. I've got this Game Boy Pocket that we'll take a look at today, and I don't know very much history behind this particular one, but I bought this under the condition that it's kind of finicky at powering up. Sometimes, supposedly, it'll work. Sometimes it's got issues, and it might take like maybe some fiddling with the power switch to get it to stay on. Yeah, not sure exactly what's wrong with it. It could be as simple as something there with a switch. It could be something else. No idea. But let's go ahead and bring it down here. Let's test it out. I actually have not tested this out for myself. And in here in the battery compartment, one thing that I did notice is that it looks like it had some batteries in there that may have leaked at some point. It looks like the terminals have been cleaned up to a point. They're not exactly spotless, but they don't look like they would be too problematic if I put some batteries in there to test it out. So let's go ahead and do that. Got a couple batteries right here. They are fresh, so these should not be an issue at all. I'm going to put this in here just so they don't fall out. And we're going to test it with one of my favorite games when I was a kid. This is Sneaky Snakes. So I know that this cartridge works perfectly because it works great on other Game Boys. So actually, I didn't even look at the cartridge compartment there to see if... no, that looks... I mean, it's going to be kind of hard to see in there, but it looks totally fine. So it doesn't look like maybe it'd be like a contact issue. Let's see what happens now. Set it down. It's powered up. And nothing. So let's mess with the switch here. Nope, it is not powering on. Let's wiggle the batteries around while the switch is on and see if anything happens there. Nope. Contrast, not going to do anything. Yeah, so looks like it's just not getting power. Pushing on the battery compartment, squeezing this. All right, well, let's open it up then and see what's going on inside. It doesn't appear to be like a dirty switch or anything like that. It still doesn't stay on. All right, well, let's just turn that off, remove that. Take these batteries back out. And I've got a tri-wing screwdriver here ready for this. So we'll remove all 6. I've actually never opened up one of these Game Boy Pockets before, so this is a first for me. Okay, and that's the last screw there coming off. That screw there from the battery compartment looks like it got somewhat corroded. It's not like crazy corroded, but it does have some staining. So let's get this open and see what that looks like. Nothing obvious other than the fact that these battery terminals there are kind of crusty looking, but not too bad. There's a power switch. I can't tell off the first glance there that there's anything wrong there. Yeah, I guess while I'm in here, I'm actually going to remove this battery terminal there, maybe soak it in some vinegar to get it cleaned up. So it looks like I should be able to do that by pushing a little tab right here behind the battery contacts. So I can get it to pop out. And there we go. So, yeah, look and see how crusty that is. Let's look at that under the microscope. Yeah, so look at that. It's pretty crusty, although the actual like surfaces there where the battery touches don't look like they would be a problem. Like they're not insulating the contacts or anything like that. But I did just notice something right here on the actual board. That switch here looks like it doesn't look all that great right there. Looks like there's been some corrosion by the power switch. That's kind of odd. And it looks like the same battery stuff. Not just there though, also right here by the contrast knob. You can see that there's a bit of some corrosion there by the on the pot, and as well as other stuff around here. That there looks, the pins on that one look fine. On that crystal there, that looks fine. Around the CPU, that all looks pretty good. That amplifier IC looks pretty good as well. The pins on the volume knob look pretty good. On the port right there. Looks like we've got a little bit of something right there off to the right. Not too bad, but yeah, definitely looks like there's stuff on the opposite side of the board that's going to require some attention. And as well as this switch right here definitely needs some looking at. So I might be removing that switch and maybe cleaning it internally. And then I'll try to put it back on and see if it works. But yeah, definitely going to have to remove this board off the casing here and take a look and see what's going on the opposite side. Could be that battery leakage just sort of like made its way and the liquid just kind of coated the board on the opposite side or something. So yeah, let's remove the rest of these screws, and these are actually Phillips, so much easier to remove. There's a few screws around the bottom here. There's looks like 3, and I think that's it. I just see these 3. Doesn't seem to be anything up there because they're held in by the case screws. But let's remove this ribbon here. That's going to go to the LCD. That's good enough right there. Okay, that's all 3 screws out. This board should lift up, and there it goes. So yeah, we can see right there where the electrolyte has kind of made its way down or up the board. The headphone jack right there looks pretty corroded as well. Yeah, the buttons right there, you can see there's a little bit of bluish green looking stuff. And on the buttons right there, that's going to need some cleaning. Doesn't look to have affected anything right here on the LCD, which is good. Yeah, this all looks okay, except for the little bit of cleaning I'm going to have to do there. So I'll set that aside, and we'll focus on the board. So yeah, you can see right there. Oh man, it made its way in there. So I'll probably remove that from the board to clean it up. And there's not a whole lot of corrosion on the board. There is some stuff in there, like some of these vias. We'll have to check and see if it's affected connection to the opposite side. A little bit right there. And that stuff right there. Now, I don't know how the power jack is wired in here on the board, but if the battery voltage goes through there, and then when you stick in a barrel connector, it interrupts the battery, it's possible that that's not making very good contact inside. So I'm going to remove that as well, along with the headphone jack. I'm going to remove these battery terminals, and I'm going to remove the power switch. Thinking about removing the contrast knob as well, except that I cannot take that apart because it's basically riveted. The knob is riveted onto that, so I may just try to clean it up as best as I can externally and then spray some of that deoxide stuff on the contacts or on the actual pot there to maybe clean it up. I'll work it around a little bit, and I'll do the same with the volume knob. I'm just going to spray a little bit of that deoxide in there and work it around to get it clean. And then I'm going to try to brush all this other stuff off here. I'll use some like alcohol, try to get that all cleaned up, and we'll see where that gets us. Just going to put a little bit of flux on these soldered points here where the battery contacts are. And hopefully that'll facilitate them coming off the other side when I heat them up. So here we go. There you go, that's coming out. Okay, that one's out. Now I'll try to take that spring contact out. I'm going to heat it up and push with the soldering iron down to get them to pop out. But it's working. There he goes. It popped out. And just going to clean them up a bit. I'm also going to try to clean up the solder off of the contacts there where they're soldered into the board so that I don't have to struggle pushing them back in. Apply some flux to remove these 2 connectors off the board. And I'm going to try to suck those out, except that I just realized my solder sucker's not plugged in. Okay, this is hot now. Sure, it's clear. It is. Okay, let's try to remove. Okay, and one other thing I will remove, just so it's not flapping around the breeze here, is this speaker. And you can see that the line here closest to the edge of the board goes all the way to the outside. The inner one goes closer to the inner one as well, so that's easy to remember. I guess I can try to remove as much of the solder as I can using wick. and seeing if that releases the switch. If not, I may need to maybe like heat the edge of the board with like some hot air from underneath. That might help me release the switch. So do this again where we put some flux around here. All right, let's go to town on this with the wick. See how the shell there is moving around. Okay, that's loose. Ah, whoa, 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 don't break any pads. Oh, there we go. Let's just clean these pads up a bit. Nah, I'm going to trim that back. Ah, good. All those pads look pretty good. Okay, so let's wipe off all this flux. And we should be able to do like some continuity checks here on the switch contacts and see if they're going to where they're supposed to be going. Make sure that nothing on the board is broken, like we've got broken traces somewhere due to corrosion. And like I said, I'm going to take this one apart. I'm just going to clean off some of this flux that's like underneath it. Let's see what this looks like inside. All right, I think I'm going to have to use a blade here to be able to get in there and pry upwards. There he goes. Can't tell if that contact right there is like completely gone or if it's just dirty looking. That right there is not too bad looking. That looks okay. Let's see what this looks like in there. Oh yeah, look at that. That's like definitely crusty looking, but it looks like it can be saved. This right there. Oh, maybe, no. Is it cleaning up? Yeah, that's definitely cleaning up. Oh, perfect. Yeah. Oh yeah, that's doable. Over here. Yep, that's good. So, well, the good thing is we're not really missing much. It looks like it's just a coating of nastiness there. I mean, some of the plating looks like it might be gone from right there, but as long as the piece that slides on there is able to make contact with it, it should be fine. What I'll do is I'm going to give this a really, really good cleaning, and I will lubricate the inside with some like dielectric grease. And let's see what this the wiper here looks like. I mean, yeah, it's crusty, but it's not missing any part of it. Yeah, should be fine after a cleaning. Not. I almost thought I lost that. Now, I was kind of hoping that this would come out, but it feels like it's molded into the plastic, so it's not going to come out. But I should be able to clean it up with a brush and like some contact cleaner or alcohol. So yeah, we'll get this all cleaned up and I'll put it back together, and it should work. Back on the board side, let's get this section here cleaned up. All right, I'm going to spray this area with some alcohol there to get that to soak in. Give this a wipe with a brush on that capacitor. It looks a bit stained, but it doesn't look like it's eaten through it or anything, so it might be okay. It's a good thing that none of the corrosion appears to have affected this ribbon connector. Definitely a via right there that may need checking. Make sure that it's making contact to the opposite side. I'm going to use this brush as well to scrub in there so I can make sure I can get in between all of those pads. Get rid of all the corrosion in there. That corrosion is stubborn. Looks like we got some right there still. So I'm going to scrub a little more with the brush. Try to get as much of it out as I can. This side over here looks pretty good. Maybe just a tiny bit right there. Yeah, there's still a tiny bit right there. That right there looks a little better. It looks like maybe it might have gotten like underneath the solder mask. Yeah, that's coming off. Yeah, so I got those mostly cleaned. I think and they're tiny. They're tiny little pads here, so yeah, there's more right there. All right, I think that's about as clean as I'm going to be able to get around those button pads right there. The ones to the right, I still need to do a bit of cleaning. You can see that there's still quite a bit of corrosion underneath the solder mask in like this area, and that's flaking off. It's like right there. Well, that one between those two has a bit of corrosion in between. Oh, looks like that might have gotten eaten away completely. That's no bueno. Yeah, that copper right there is gone. I'm not getting anything scraping it. Yeah, this side seems to be worse than the left side button, which was the select button. This is the start button. Select button, not too bad. But this is definitely going to need some work. And the thing is, the button pads only make contact on 4 of the squares at a time. So you can see right there, we got 2 little round pads on each button. So we'll get this one cleaned up. Let's see how much this gets us just by trying to wipe it off with the swab. Okay, that's about as clean as those are going to get, I think, other than all those little tiny dust flakes. I hope the contact material is still in good condition, but the one thing I am worried about is the contacts on the board itself, like all those pads. Start pads here, they are pretty rough shape, and I have a feeling that some of these are probably not going to be making very good contact. So I may need to do something about those, but we're going to wait until I can actually get this thing to power up and do something, and then we'll probably have to come back to that. But in the meantime, let's see what else here needs some attention. There's one via right there that looks corroded inside. We're going to have to check continuity from that side, or this side, over to the other side, and I'm trying to keep track of where that is. I mean, the vias are so small that I can barely see them with the naked eye. So 2 right there. Looks like, shoot, they're underneath the cartridge. I'll go back and deal with the board in a bit. For now, I want to get this switch going so that I can put it back on the board. I'm going to soak the inside there with some isopropyl alcohol, and I'm just going to try to scrub all that nastiness out of there. Get it as clean as I can. I'm going to flip it over and clean the outside as well. Alright, that definitely looks better. We'll set this one aside and finish cleaning off the other parts. Holding these little tiny parts is kind of a pain because of how small they are, and I can only do so much with the tweezers. Oh no, that thing bent upwards. We don't want that. Hope this doesn't break. If this breaks, we have a totally different issue on our hands. It's so hard to grab it with this tweezer. It's not wide enough. Or not that it's not wide enough. The section here is not wide enough down at the base where I have the most control. There we go. I got it somewhat there. Can I bend this back without breaking? Drum roll. That does not look good. I think that's about as... Yeah, that's about where the other one is. So, I didn't think it was going to be that fragile. Well, let me spray a little more alcohol in there, and I'll just try to scrub a bit of the middle there with this other set of tweezers. Maybe if I take the brush and I just gently brush away from the contacts. Okay, I think that's going to have to do it for that one. I don't want to torture it anymore. I'm just going to gently rub it so I don't move it around. Okay. Those are still intact. We'll set that aside. Okay, now this one here, I don't have to worry too much about. Get it soaked, and then I'm going to scrub it. All these weird little bumps on it, but I don't think they're going to hurt anything. They're just... What are those? Doesn't seem like it's flaking either. So yeah, not sure what that's all about. Okay, I'm ready to put this switch back together. But one thing I'm not totally understanding here is why they went with this type of switch, because technically it's only like a 2-position switch. Like it's either over here or it's over here. But this base can actually be for like a 3-position switch. So when we have the switch over on this side, we see that it'll make contact between these points and these points in here. And then when we move it over to the opposite side, now we have contact between these points and these points over here. So there would be a third if it was able to like sit right in the middle, in where it's making contact between this points, which, I mean, all of these all correspond to like just one pin. So it'd be making contact between this pin and this pin. But since it's only a 2-position switch, and we just want to make sure that it's making contact between this one and this one and this one and this one, once it's all back together, I'll be able to test it and make sure that we've got some pretty good continuity going on there. But first thing I'm going to do is I'm going to fill the inside here with, coat it all with dielectric grease. And that way, hopefully, it'll prevent corrosion from, continuing to happen, or at least like inhibit it a bit or something. All right, I thought I was recording, but apparently I wasn't. So I'm just applying grease in here. I'm just using this little tub of super lube stuff, and I'm just trying to get it all to coat those contacts inside. All right, and when I put the slider in there, then those are going to get coated. So I'm not worried about putting in any more on that. I am going to want to put some like in here though, just like a very light coating, just so that the switch can, have some lubrication from the top. But let's get this inside. All right, so that's good in there. Just going to tack this onto the top there and give this light coating. So let's try to get it to snap on there. And there it goes. So let's see if this clicks in place from either side. I mean, it never really felt like it clicked to begin with, so that's probably pretty good. And we can see that it's too much of that grease is like squishing out. So I'm going to try to wipe some of that off. It feels okay. That should be fine. So let's go ahead and check continuity. As I mentioned, it's going to be this middle pin here against this outer one, and then, well, not the middle pin, but like the one right in the center of the switch. First of all, let's move the switch over to that side. So here. There, got it. And this one. So that's pretty good. Now let's check the opposite side. I'm just going to try to do that like that. There we go. So yeah, that's pretty good. So this switch should be working totally fine now. Let's go back to the board here. And like I was saying, I don't know if the battery contacts go through the power jack first or something. So I'm going to check and see if I can get some continuity between the positive. I'm assuming they're switching. So battery terminal positive is this one right here. And let's see if there's anything at these contacts. So it's going to be like this one, or this one. Oh, and there is. So yeah, we're getting battery all the way up to the switch. And then from the switch there, the center one would be the one that goes off to the rest of the power supply. Okay, first of all, it looks like it goes off to this side of the board and down into this section. So this is probably going to be a little switching voltage regulator, I'm guessing, by seeing that there's an inductor there. But I think then, as long as the battery ground is connected to the rest of the board, let's see. No, so this is probably going to be the one that goes off to the jack back here. Yeah, so it's the negative of the battery that gets disconnected from the rest of the board when you have a connector plugged in there. Yeah, see, that's ground right there. So there's going to be basically a switch internally on that connector between that pin and that pin. So what I think I can do is I can mount this switch back on, and I can, well, first of all, I'm going to clean these battery contacts so I can solder them back on. I'll connect a power supply between the positive and what would be the ground, and we'll see if the LED here in the front even comes on. If that comes on, then that means that it's the rest of the power supply circuitry should be working. And then we can go from there, and we can do a little more testing and see if these buttons are going to work or not. The directional buttons and the A and B, those all seem to be fine, so I don't think there's going to be an issue. The audio jack there also going to need some cleaning, and that could be an issue with the speaker. If that's the speaker goes through that and it requires, switching it from there or not, I don't know for sure, but that could be a problem. So let's go ahead and finish cleaning the rest of the connectors and contacts, and then we'll do some basic testing on here and see what happens. To clean all these contacts and connectors, I'm just going to plop them into this little medicine cup here full of vinegar, and we'll be able to see them start fizzing right away. That's getting rid of all the evilness that's on them. It's always fun to watch. This one here is going to be pretty fun. Yeah, look at that. Effervescent action. And plop. Yeah, that one there's got some air inside, so it's pooping out bubbles. Gotta make sure that the fluid gets in there. Should be good. And the headphone jack. Oh, wow. That was bubbling like crazy. Stir those around a bit. Let's make sure we get everything nice and coated with vinegar. Just gonna let that sit here for a minute. While that's going, I am going to solder the switch back onto the board. And the cool thing is that this kind of self aligns because it's got those little tiny nubs there that fit into those holes. So getting the alignment right on this isn't all that difficult. And I'm gonna get the soldering iron. See if I can get this one over here on the side first. We'll get the mounting tabs first, and that way I can align it if I need to. Lost it. There we go. All right, I got that one tacked down, but now I need to try to get this other side over here. And this tip is a bit too thick. I'm going to end up melting that connector there, so I'm going to switch out my tips. All right, got a much smaller tip now, and it should be, yeah, it's nice and hot. Going to solder that one right there. And it's not going onto the board. Yo, come on. There it goes. Put it onto the board. So nice solid connection there. I am going to add a little bit more to this side though, because it wasn't very much that went on there. One, two, this end one over here, 3, and 4. There we go. And I think these are ready to come out of the wash. Looks like they've stopped bubbling, so yeah, let's start getting them out. And you can see how the coating there's been removed from the corrosion. So you just see like all the copper exposed underneath. And this here's the positive terminal. This one didn't look like it was in too bad shape to begin with, but we can see how we did lose some of the plating right there. And the rest of it looks pretty good, but that's much better looking now. This end terminal was the one that was in the worst shape, but it looks like definitely took care of it pretty well. Can't quite tell what it looks like in there, but I can take this apart. I can get these contacts out of here, but I wanted to clean them up first. They will slide out the back. Actually, I'm not sure how much I'm going to be able to take this one apart. It looks like that center pin has to come out before anything else, because everything else is like behind it. So let's see if I can pry up on this. Oh yeah, it's going. There it goes. So there's the center pin. You can see that it looks a little discolored as well. Not too bad, just a tiny bit. And now I can get the rest of these out. So that might be easier said than done. Doesn't feel like they want to budge. Oh, there it goes. And it flew off somewhere. Oh, no. I got to find it now. All right, so I gotta hunt one of those down. I don't know where it went. Let's try to get this one off here without having it fly off on me. Looks like in there, still got a little bit of a coating on it that needs to be removed. I cannot get this to pop out very easily. Let's see, I have a tweezer right here. Maybe I can use this. I bent the tweezer. Oh, sweet. I found the one that flew off. So, yeah, look at that. It's slightly pitted looking, but not too bad overall. That should still work. Okay, this piece is being extremely stubborn. I think I may just need to let that one sit in there. I can't pull it out. Now, even though I kind of doubt that I'll ever use this power connector, I don't like the fact that there's some nasty looking stuff right there. I guess worst case scenario is I can try to find a replacement at some point if I need to. But this part, I don't want like re-corroding. So what I think I'm going to do with this and some of the other stuff is I'm going to coat them with this liquid tin stuff. Although I'm not going to do it in here because this stuff smells nasty. So I'm going to do this off camera just because I need to take it outside. But you'll see the results when I bring these parts back in. I mean, actually, I could record a little clip of it with my phone, I guess. So I'll do that. Now, hopefully, I can completely dismantle this connector. Okay, these side connectors here look like I can just push that inwards, and maybe that'll allow this to slide upwards. Let's see, maybe I need a little bit of a plier action. I'm trying to be gentle, like I don't want to break anything. Yeah, there it goes. Yep, it's moving. That wasn't too bad. Still requires a little prying, but it's going. There we go. So that's one. And yeah, that's not looking so hot. Yeah, it looks a bit better right there. Actually, that one there looks like I might need to push in. Yeah. So let's see how far that gets us. Push in and out. Oops, I bent it inwards too much. But it's coming out now. I can bend it back out. And look at all of that green. Oh bueno. Oops, and I just, oh, it's right here. Yep, that's definitely affected by the electrolyte. Okay, I got 3 contacts left in here. This one looks like, yep, also got a tab up there, but I think this one I'm going to do slightly different. I'm just going to stick the blade in between the plastic and the casing there, and I'm going to pry up on the plastic while prying away on the contact part. And the blade just broke. Nice. All right, I think I'm going to just have to, I used the blade to pry out the blade. There it goes. All right, got that out. This feels like a dangerous stunt. All right, I'm going to try to slightly just push down on that tab, just a tiny little bit, just to get it to clear the plastic. That might do it. All right, something slightly more pokey. Stiffer, there it goes. There it goes, it's moving. Sweet. All right, now that one's out. And 2 contacts remaining. We got this one. Actually, it looks like there's something there. Yeah, that's definitely a switch. So that's going to be for the speaker most likely. So if that's got too much corrosion on it, we can actually see if I stick something in there, how that's going to move. Right there. So it disconnects the switch whenever there's a headphone in. Like that. So as long as these are making contact, the speaker would work, but it looks like, as you can see, the coating's all been eaten off of it. So if I don't recoat that copper, there's gonna basically turn green, and then contact might not be very good. So let's get those out of there and recoat them. So it looks like this little plastic piece here might need to come out first. I'm not sure how that's in there, so I'm just like gently trying to pry outwards. Yeah, and it's going, so I guess this is working. See if maybe if I can push it out this way. Having a hard time from the back. So let's see if both of these come out at the same time. Unfortunately, it looks like there's a tab in there too, so... well, let's use the blade technique. And I need to get it down on this side. Pry outwards. There it goes. Well, maybe that plastic piece doesn't need to come out, but I want to get it out anyway so I can more thoroughly clean it up in there. Oh, I see. Looks like it's got little plastic tabs right there. So one on that side. Maybe that's it. Yeah, I'm going to try pushing down in there and see if that gets it out. Well, it kind of gets that side moving, but this side's still not moving. So this right there might be another tab that needs to release. There we go. We got some movement now. So now I should just be able to push the rest of it out, I think. Okay, there it goes. Oh, so part of the reason it wouldn't come out is because it's got kind of like a little bulbous end. Yeah, like that. It was getting stuck in there. So it had to like clear that this little like tab in there, and then it was able to go around. So that was the trick there. So now I just got that one there left. Should be able to push that one up. This side here does look like it needs to kind of go in a little bit in order to clear the plastic. Looks like that one I might just be able to push up with the plier like this. Yeah, there it goes. There it goes. Sweet. So now this entire case here is empty. I could probably stick something in there to try to clean it up a little better. So you can see we still have a lot of residue in there. So I'll clean that up a little more. And I'm going to finish cleaning up all these contacts. And then I'll show you how I'm going to recoat them. Oh, I almost forgot. On this power connector, I can actually remove this top one just by prying it up off the sides. And it looks like this one's pretty much okay. That one doesn't really need any work. And since I only have the one contact left in here, I think I'm just going to stick this entire thing inside of the liquid tin liquid. And it should just be able to coat everything that's exposed. Okay, I'm hoping it's going to be easy to tell what's going on here, but got all the pieces here in this little glass cup that I only use for this liquid tin stuff. And when I pour it in, you'll see that it's going to immediately start coating all of the metal parts. And they're going to turn to like a shiny silver color. So I just put enough in there just to cover them all up. And it's going to just have to sit there for a few minutes. I'm going to like swirl them around. So kind of see stuff kind of bubbling a bit in there. It's reacting something. Alright, so we'll let that go for a bit, and hopefully they'll be coated by the time we're done. The headphone jack, I'm going to try to clean the inside of it with the ultrasonic cleaner. So I've got this water here nice and hot, and I'm just going to put this on I'm going to try to hold it here with these tweezers. And I'm going to dunk it in the water, and while I hold it in there, I'm going to sprinkle on some of this ultrasonic cleaning powder. I should hopefully get it nice and clean on the inside. I do want to get the powder on the inside though, so that's like the best effect. Oh, there we go. Got some in there. There's like one particular spot around here somewhere where it gets like the scrubs the best. I just gotta move it around. I removed the parts from the liquid tin and I rinsed them off and dried them. And one thing I kind of did forget to mention that's very important is that you should really wear gloves and eye protection with this stuff. Did I mention it's really nasty stuff? But anyways, that's all done, and I have them sitting here on the bench now on this little shop rag. And as you can see, they definitely look better than they did. It didn't quite do as great of a job as I would have hoped, but I mean, it's got definitely a lot less exposed material, so that should help prevent them from corroding too quickly again. These, they still look kind of blotchy, but I think they'll be fine. So now it's just a matter of putting all this stuff back together and soldering these two back onto the board, putting that back into the rear case. Although I still do need to clean up the rear case so that I can remove all of that residue, like corrosion and stuff there. So we'll do that in a sec. But for now, I'm just going to put these back together. Okay, so with nothing plugged in, these two pins right there should have continuity. So let's make sure that there's continuity there. And there is. So that's all good. Now with a plug inside the jack, it should break continuity between those two pins. So let's go there, and no more continuity. So that's good. Now the ground, which is this outside one, and this thing's all mangled. So try to straighten it out here a bit. There we go. All right, so I'm going to touch this one here, and I believe ground was this one. So should have continuity there. Okay, not that one. That one. There we go. So that's working. And this here is the tip, and it's going to be one of these two. Okay, so it's that one. So resistance is a bit high, but it should be. There it goes. It should be fine. Could be the meter leads here touching aren't touching very well. So this here should be the ring, and that's going to be this other contact on this side. I'm not touching it very well. There we go. So yeah, that's all working. So this jack should be good, and it can go back on board. And this one here, this is the power jack. As long as we've got continuity between these two, that's pretty much the most important thing. So yeah, that's working fine. These two are just for basically supporting the jack from the outside, so they don't really have like any internal connections. The only other thing is the tip there, but that's, I mean, that's going to make contact with, you know, whatever barrel connector gets plugged in there. So we can't really do much about that. So we'll leave that alone. And now we can start populating stuff back onto the board. The positive terminal is going to go here, so I'm going to snap that into place. And that went in quite nicely, so that's good. And this is the negative battery terminal. That can also just snap into place. And the cool thing is that since they just snap in, they're going to hold themselves in while I solder from the opposite side. Okay, so that's it for those. There we go. This one here does not want to stay, but I can just hold it while I solder from the other side. All right, and that one's good. Okay, with nothing plugged in, let's leave this switch off and see if we're getting continuity from the negative battery terminal to ground. And we are, so that means that this jack here is working just fine. And now we should have continuity from this battery terminal over to, what was it, the middle, or was it this side here? I think we already checked that. Yeah, so that's fine. So, since we've got all that stuff installed, I think we can apply power and see if this LED turns on. So I'm going to get the power supply set up here. All right, I've got the power supply set to 3 volts, and I'm limiting it to just 300 milliamps for now. So switch is in the off position. I'm going to plug in the 2 banana leads here to, let me double check here, make sure, yeah, positive there, negative there. So that's good. Okay, see what happens. So negative going in. Here we go. Let's hit the power switch. Hey, LED turned on. And it's pulling 44 milliamps. So that's probably okay. Let's see. I'm going to take this off of here. Let's just see what happens if we hook up the LCD. Put the board in there. I'm not going to put like all the buttons or anything on just yet. Let's just see if anything happens on the screen. Positive there. Got the negative there. Okay, here we go. And where's the switch? This side. I thought something would have showed up. Well, we got a line there, but could be the contrast. Nah. Huh. Pop a game in and see if it does anything. And let's see right here. Yeah, nothing showing up on screen. That's not a good sign. Oh, something right there. Oh, there it goes. Oh, yeah, this thing's like finicky right there. So it is working. Looks like, yeah, that pot there's going to need some cleaning. So I'm just going to turn this off. Pop that out. Okay, so it was this one right here. I'm going to take it out of the case because I don't want to get a bunch of that contact cleaner in there. Just going to try to spray it inside of that. Hopefully the actual material isn't like deteriorated to the point where it's just totally bad. I'm gonna kind of work that back and forth a few times. Spray it back out. All right. Just leave it at that for now. Oops, kind of we're sprayed over here a little bit. Okay, let's pop the game. Let's make sure that's off. Game in. Positive. Negative. All right, let's see. The switch. There you go. Okay. Whoa. No, it's still touchy. Ah, that's yeah, that's not a good sign. It might mean that this pot is a little bad. So, yeah. Well, I can't push start because there's no start button, but yeah, this. I mean, it's somewhat better. It's not great. I'll try cleaning it a little more, see if I can get it to work better. Unfortunately, yeah, this pot here is just not working very well. It's going to have to be replaced. But now that we know that at least this unit powers up, we can at least test the audio and we can reassemble it enough to run off batteries, and then I'll see if these buttons here are working at all. So at least we'll have a good idea on whether or not this pot here is going to have to be replaced as well. But I don't think there was any corrosion on that one really. It was mostly on this one. So I will resolder in the speaker after I clean it up a bit because there's a bit of dust up here on it. So just going to give that a little bit of a wipe. All right, speaker back on. Okay, I'll need to put the small screws on here just to hold the board in place. I'm only going to do that middle one right there. That should be enough. Oh, I almost forgot I need to finish cleaning the back here. And I'm just using a cotton swab here soaked in vinegar to get some of this stuff here out of the way. Oh, that one's bubbling right there. Okay, so that's fairly clean there. Probably about as clean as I'm going to be able to get it. Just going to put the cover on, and I need to put in the battery contacts for the opposite side. All right, let's put the batteries in and make sure that this is in the off position. It is, and pop the game in. Let's see. So it comes on, but can't see anything. Oh, there is sound. So yeah, that's working. Volume up here. See if the volume knob works. Try to get up close. Yeah, the volume knob seems pretty responsive, so that one's fine. It's just the contrast knob that's going to need some help. Let's see if the start button works. Nope, the start button doesn't work. I can't do anything with select, but yeah, I can't start the game because that start button is no bueno. Fast forwarding a few days, and this is where we are at. As you can see, I have removed the contrast, the potentiometer, and it's right here. Well, we can see that it had 5 pins that were soldered onto the board, as well as the 2 here for mounting that are basically just grounded. Now, fortunately, I was actually able to find some schematics for this Game Boy Pocket, and we see it here on GitHub, and there's various pages here that are basically like dedicated to like specific parts of the circuitry. And what we are interested in right now is this contrast adjustment. So if we look at that a little closer here, we see that the potentiometer is basically just adjusting resistance between a VEE, which is on the schematics here, it says it's negative 18, and this VR pin on pin 18 of this IC. So that helps us see which pins are actually being used on the potentiometer. It's basically just using pin 2 and 5. 1 is tied here just to basically provide like the full resistance between these 2 points when the wiper's like all the way up on this side. We can measure the resistance between pin 2 of the potentiometer and pin 5 to see what's going on there. And we could also measure the total resistance between pin 5 and pin 1, which should be 30K. But let's see what we're getting on the original pot. So move that out of the way here. Move this into the shot. So pin 1 is over on this side. Pin 5 is over on this side. Let's bring up the potentiometer there, or resistance. Let's, between this pin and this pin, it's measuring about 80K. And if we turn the knob here, we see that this resistance isn't really affected at all. And it shouldn't be because, well, we saw right there, it kind of jumped. But it's not, oh, whoa, 104. So it's not dealing with the wiper there. The wiper is going to be this pin right here. And this pin right here, pin 5. So as we move this along, we're going to see how it's just going to like totally jump all over the place. And right there, it's going down because I am, getting those two closer together. But we see right there, we get like points where it just like jumps up like crazy. And so that's why the contrast is so like messed up. See, now I'm all the way at the end and now it's 300K and now it's like open completely. So it's, it's extremely unstable. So that's why this potentiometer is not doing what it's supposed to. Now, unfortunately, this is a 30K potentiometer and I could not for the life of me find, or at least easily find, a replacement that was identical to this. However, a bunch do come up, like when you search like on eBay and stuff, and they're sold as volume and contrast potentiometers. So this is a 10K potentiometer. It does work exactly the same, and if we measure between these 2 points there, we see that we have a 10K total resistance. And if we measure between pin 2 and pin 5, and we adjust the pot here, we see how it does change. Well, actually right there, I'm like towards like that end, but if I kind of like slowly go in this direction, we'll see how it increases. Right here in the middle, it should be about 5K. We keep going, it keeps going up, 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 and up until it gets to about 10K. So 10K is a third of 30K. So I don't know how much of a range of contrast we're going to be able to have with this 10K resistor, but I thought of a way that we can maybe try to get like a baseline of when we have a sort of like a in the middle contrast on what would have been like the original pot. And so maybe we can kind of tweak the circuit a little bit so that this 10K can sort of have like a somewhat similar response. It's not going to be exact, but it should be good enough for at least to have some adjustment. So what I did is I went digging through my pot stash and tried to find like a 30K pot. And unfortunately, I do not have any 30K pots. But however, I did have this little bag here of that I bought from MTJA of a bunch of like assorted potentiometers. And it's technically a pack of 14. It comes with 2 values each. But I bought 2 of them, so I had a total of, 28 potentiometers there. And so, yeah, lots of assorted values. And this didn't have any 30K potentiometers either. The closest I had was a 20K and 50K. And the funny thing is that I measured them. The one that's supposed to be 20K measures more like 14 and a 15K total. And the one that I actually ended up with right here, this is a 50K, measures more like 44K. So this pack of potentiometers was actually didn't really cost much. And now I think I know why. They were probably like rejects. And I mean, for most things, the accuracy of the total resistance is not going to be all that important. So, I mean, they're useful and they don't feel like, they're like cheap or anything. They actually, the quality feels okay. It's just the values are not exactly what's on the package. But what I'm going to do is, as you can see, I've already soldered 2 wires onto here. So I'm going to solder the other end over to the VEE and the VR pins that are thankfully like little vias right there on the board. And we're going to reassemble this up to a point. I'm going to have this potentiometer sticking out the side. And I want to get sort of like a baseline resistance, as I mentioned, of when the contrast is somewhere like in the middle. We'll see what that resistance is. And what I'm thinking of doing is maybe I'll adjust this so it's like in the middle of where it's 5K, and add a resistor in line so that when this thing is in the middle, it measures about the same resistance as what we get from here. And then maybe we'll have some adjustment to the contrast, you know, where we can go up a little bit or we can go down a little bit. So let's see how it goes. I'll just do all that real quick, reassemble it, and then we'll power it on and see what we get. All right, so I've got the game in there, I got the batteries, and I have the potentiometer here sticking out the side. So let's see what we get here. Let's turn it on. We can see that we see nothing, so let's adjust this. Okay, so this way here, it's basically complete resistance between these two pins. And as I turn it this way now, I'm turning it counterclockwise. It should darken up at some point. There it goes. So yeah, we see how like this is a lot more responsive than the original pot was. So I think, let's see, that's like kind of dark there. I'm actually having to look at this through the camera because I have it. Yeah, I'm at an angle here. So let's adjust it maybe until we. It's a little too light. I think like right about there should be like a pretty good kind of like midway like contrast point. So now I will remove these two wires off here and measure the resistance of the pot and to see what that is. So turn this off, and I'm going to try not to move that potentiometer at all. I don't want to like measure resistance on the board there. So let's see what we get there. So about 8K. Okay, so if we set this pot here, the replacement pot, then to the middle point where we have 5K, we would just have to add about 3K resistance, and we should have about the same amount of contrast as this one gave us. So let's go ahead and do that. Oh yeah, and two more minor things about the replacement potentiometer versus the original one is the original one, it's kind of hard to focus there, but when they both sit at about the same distance, the new one sits a little higher up, like a little more proud than the original one right there, like the actual plastic knob. But I've already sort of like test fit this in the case, and that doesn't seem to be a problem. It's just that like this knob isn't like centered in the slot there. It's just like slightly more to like towards the back, I think it was. But I mean, other than that, it fits just fine. And as I was mentioning, the legs here, they are a little bit longer, or I mean, you can tell that they're longer than the original. So when it sits there, you see that they kind of stick out past the pad just a tiny little bit. So I am going to just give those like a little bit of a snip to shorten them up. And I mean, that should be totally fine. Now, as I was saying, that we were going to have to add a resistor between, at some point, you know, between this potentiometer and pin 18 of this IC right there. I think we got off super lucky. Check this out. So on the board here, this is pin 1. So pin number 5 is where that VEE voltage comes in. And it goes to that via there, but that via there is just a test point on the opposite side of the board. It does not go to anything, so we don't have to worry too much about that. We follow this trace. It kind of goes over here in this direction. It goes to here. Look at this right here. That almost looks like a pad for a resistor. So I think what we can do is we can snip this right there. Just sever it. Remove some of this solder mask and put a resistor in line right there. A little surface mount one. And we should have, when this is in the middle, or the new potentiometer is in the middle, we should be able to get that 8K resistance. I don't know if I have any actual like 3K resistors, or maybe something close to that, maybe like 2 point something. But I'll see what I have, and hopefully I have something that's about this size that I can stick in there. So let me go digging real quick. All right, people, I went on a resistor safari in the garage, and this is what I came back with. So I got these 3.3K resistors, and these are all like brand new. This is a 1206 sized part, and unfortunately, it compared to those pads that are on the board, this resistor is much bigger and is not really going to fit on there very comfortably without me having to do like some sort of a weird kind of positioning there. And so I thought, well, I guess I could just solder this to like this pin right there, and then run a little piece of wire from that terminal to that pin, sever this right there, and that would work. And then I thought, well, if I'm already placing a wire there, I might as well just use like a through-hole resistor. And so I actually have some 3K resistors, and this is a quarter watt. But as you can see, trying to lay it across those pads there is going to be a bit of a work in trying to shape these leads, which is not ideal. So it turns out I do have some 3.3K resistors in this eighth of a watt size. So I can put that right there. And I mean, that'll work. It's a bit bodgy, not really what I wanted to do. I wanted to just be able to use these pads. But lacking any resistors that actually fit that size, I would have to order some, which just means that this video would take even longer. So I'm just going to use this one here, at least for now. And I mean, it's not like this is really that big of a deal. It will be fine. So we'll just stick this one in here. Now, I did mention that these leads on the new potentiometer are a bit on the long side, so I'm going to trim them back about that much. I mean, I could trim them back about like even like half of what they are. So that right there should be okay. And we'll just go all the way across. Like that. So now that should allow these to completely stay within the pads right there. So yeah, that looks pretty good. And I do need to cut this first because it might be a little difficult after I put the potentiometer in that spot. So let's see. All right, that should be severed through completely, but I can do a resistance check between that point and make sure that I don't have like any continuity. Okay, here we go. So between here and here, it's looks like it's completely open. Make sure that this is actually working. So yeah, that's working. So yep, that's good. All right, so let's get this potentiometer soldered in place. I got to put some solder at least like one or two of these pins first though, just to make sure that it stays in place. All right, cool. The second one from the right there got a little more solder than I would have wanted it to, but it's fine. And now just this side. There we go. And now for the piece, the resistance, we're going to put the resistor right there. And as you can see, I've already trimmed one side. And that's just so I can tack on the lead to that end of that pin right there. And as you can see, I kind of bent it like this so that way I can have a little more control, like with my fingers here. And I can try to hold it down without burning myself. Right there. So I'm going to start off by just adding a tiny little drop of flux right here. And I'll put a little bit of solder on the end of that resistor right there. Okay, now I should be able to just tack that on right there. This is still difficult even with bending that lead. Got it right there. All right, let's tack that down. I could kind of go over that lead there just a bit. It's not sticking. Come on. There we go. Okay, that's not too bad. Now I just have to attach it to the end of that potentiometer. And the flux from the solder should be enough for this one. There we go. I just need to try to trim that lead. So there we go. So that should work. Clean off the extra bits there. All right, let's test out the new contrast knob. All right, here we go. Really? Come on now. Nothing? What? Ay, ay, ay. Unfreaking believable, man. This resistor is bad. Check that out. So, oh, no, I'm freaking dumb. That's a 33K resistor. In order for this to have been a 3.3K resistor, it would have had to been orange, orange, red, not orange, orange, orange. The red here, that's the tolerance band. So, yeah, that's my bad. All right, well, since I don't really have any other good options, I'm just going to use that 1206 device or resistor, and I'm just going to put it there and put a little lead between the pin and the end of the resistor. But I kind of want to insulate this area a little bit better. So I'm going to put a little piece of Kapton tape like right here. And I'll just try to cut it here close to the IC. And across this way. All right, just like that. Make sure that this is nice and flat. And I'm just going to put a little bit of flux on the end of the... right, a little bit of flux on the... Good enough. And I'm making sure that it's flat and like butting up against the pin there. So that should be good. All right. There's enough there on the tip. That's going to coat that. That's good. Yeah, that's good right there. We'll just run this over. Let me shape it a little bit though. Something like that should be good. Now for this side, I'm going to try to be quick because I don't want the resistor to heat up too much and desolder the opposite side. So let's see if I can do this fast. Actually, I don't want to desolder from that side either. So, oh, come on, come on. There we go. That wasn't too bad. So now I just got to trim this. There we go. And obligatory quick cleaning. All right. All right, so I've got the potentiometer there set to the midpoint again. Going to put some batteries in the cartridge. And there we go. So, power on. Very good. That's looking pretty good right there. Yeah, that's about where I would have wanted it to be when it's in the middle. So if we go up, it gets much darker. We go down, it's good. Got some pretty good range there. I mean, obviously, why would you want this thing to be completely like light contrast there? So that's way too light, you know, to be like playable. And this is obviously like way too dark. But we put it like right around the middle, and it's nice. It's really good. So, well, last things to deal with is these buttons. And there was a few little bits of corrosion that I noticed were still on the board, so we just got to clean those up a little bit. But we're almost there. We can taste the finish line. Now for the star button pads. What do we do about these star button pads? Well, first of all, I started by trying to analyze how bad the damage was. And so I looked at it under magnification and tried to figure out, you know, how it was all wired. And this is kind of what it is. So we've got alternating like sets of pads that go to two different traces on the board. We've got one that comes down in this direction. It makes contact here. And then this is these two pads here are linked together. This pad is linked together with this pad, and then this pad is linked together with that pad. And from this other trace that comes down, we've got these pads right here, all being part of the same trace. So whenever you push the button, because they're circular, you have like one here and one here. It's going to like make contact across these pads, and that's how you get your input. Well, unfortunately, the damage that's done to this board by the corrosion has caused this to break, this to break, this to break, this to break, right here, and right here. Actually, now to think about it, this one was okay. but you can see that there was definitely like a lot of damage done actually, and I think this one right here was broken as well. Oh no, actually this one was fine. So you can see we've got quite a few places where contact is broken, and the easiest thing to do would be to like solder some thin traces of like wire, between all of these pads where the contact is broken. But I didn't really like that idea all too much, because then it's going to, whenever you push the button, it's going to make like indentations in the rubber. And I'm thinking maybe like prematurely wear it out or something. So I kind of busted my head for a couple of days thinking of how I was going to solve this problem. And I thought, well, what if I could just replace the pads with, something here that would make contact and, completely take over the job of what these are doing. So I came up with this. I tried making some replacement pads. So I'll try to quickly here show how I did that, because I actually didn't record the process because I wasn't sure if it was going to work or not. But it seems promising. So I think this may be the ticket to fixing those pads there. I started off by basically just taking some measurements of like, what's already on there. And these are probably not going to make too much sense just looking at them like that. But so I ended up using KiCad to basically make like a surface mount pad. And so I've got all the like the squares there for all these pads, and I've got the connections made. And I left these little nubs here because that's where I'm going to try to attach them to the original traces on the Game Boy board. And so these are all wired basically in the exact same arrangement that they are on the original pads. And after I had that done, then I laid a bunch out on a PCB in the PCB editor, so I could print this out on a sheet of paper, like this. So, and I did I did a bunch of them because the laser printer that I'm using here doesn't exactly make a very dense prints. So by putting a bunch on the paper like this, I could try to like select one that looked the densest, but they all look pretty much even. So I ended up using just one from the corner over here. You can see I got like multiple sheets because I was trying like multiple things, and there's slightly like different variations of it because I modified the pads a little bit. But after I had that done, I cut out this little mock-up that I can use to, make sure that this was all the correct size to fit where the original pads were. And so, yeah, it looks like it's going to work pretty good. This is where they would sit, like right there. So this was all looking pretty good. And all I had to do now was transfer this over to some copper so that I could etch it and actually make the physical pads. And for that, I used this roll of copper tape that I bought from like Ada Fruit forever ago, and I still haven't like really used for anything. This is like copper foil, and it's very, very thin, and it has an adhesive on one side. But what I wanted to do was to coat the copper with that same liquid tin stuff, because I didn't want it to just be like exposed copper making contact with the buttons there, because eventually that copper being exposed is probably going to like develop oxidation and probably not make as good contact anymore. So I took a sheet of laser printer transparency paper and cut out these strips, like as you can see there. So that's about 3/8 inches wide, and I cleaned it off with some like alcohol so that it's doesn't have like grease or anything on it that's going to prevent the copper from sticking to that. And so I took a small piece of that copper tape, about that big, and I stuck that to the end. And I try to make sure that it was like really, really well like stuck down so that like liquid can't really get underneath it. And I didn't do this originally, but I think maybe like running a like rounded sort of like a tool or surface like around the edges may have helped a bit to keep it like pretty well sealed. Maybe like right here in the middle too. And so after I was happy with the way that was attached to the transparency, I cleaned it off again with like a bit of alcohol. And then I just took some like really fine like body sandpaper, and I just kind of buffed it out, made it kind of shiny, removed some of the surface oxidation that may be on it. And after I was happy with that, then I cleaned it off with alcohol once again, so it's nice and like shiny. And so after that was done, then I took the little piece of paper strip and the copper, and I dunked it into the solution of liquid tin and let that sit for about, I don't know, maybe like 20 minutes or so. Just wanted to make sure that I had a really good coating on it. So that being done, it looked something like this. After rinsing and drying off, You see we've got a nice tin layer on one side, but the side that's stuck to the transparency paper is still just copper. So I wanted the tin side to be the upper side where the button actually makes contact, and the copper side to be the bottom where it's actually attached to the circuit board. So I had to somehow transfer this to the other strip of transparency, because I want to etch it from the back. I don't want to etch it from the front. And so I had to figure out some way to be able to take the piece of copper and put it on the other strip. So what I did for that, once again, I cleaned them both off with alcohol and made sure that they don't have like any grease or finger grease or anything like that on them. Let that dry for just a sec. It dries quickly. I took some contact cement, put a very thin layer on the end of both of these, except that with the brush, I'm not exactly going to get like a very evenly thin layer. It's going to be kind of blobby. So after I had it on there, I just took a razor blade and just gently passed it over the surface of the copper strip, just to make sure it's like nice and like a flat layer. Really hard to tell, but you can kind of tell there that there's a bit of glue on that. And I did the same thing with the second strip. Can't really do this steadily, but you kind of get the point. Like that. Let that dry for a little bit. Okay, so after letting those dry for a bit, in a process that can pretty much only be done once, I have to carefully line these two sheets up and allow the two surfaces with the contact cement. You got to get the alignment right there first. Okay, like that. And let those two come together. And that forms a really strong bond between the coated surface of the copper and the other side of the transparency. And the contact cement doesn't stick all that great to the transparency, but it will to the copper. And so now I can just peel this off, and it'll leave the copper piece on the surface of the other strip of transparency paper, just like that. So now I have the tin coated side stuck to this sheet of paper, and the adhesive side of the copper is now facing outwards. So the next thing I need to do is get rid of all that adhesive on the copper, and that was actually not too hard. I ended up just using a cotton swab and some isopropyl alcohol. And it takes a little bit of work, but it does come off. And it doesn't seem that the alcohol affects the contact adhesive, so it remains, the little piece of copper remains stuck to the transparency piece. And now that all the adhesive has been removed from the back of the copper, I actually used the piece of wet or dry sandpaper again. And by the way, this is 1000 grit, so get a little bit more water on that. And now I sand this side of the copper. And I don't put a lot of pressure down on this. I don't want to like pull the piece of copper off the paper there. I just want to rub the back a bit so that the toner will stick to it. And once I think that's okay, then I just give it a wipe. Normally I'd clean the copper with like brake cleaner or acetone or something before I apply copper, but in this case, I'm not going to be able to do that, I don't believe. So I just basically just leave it like that and just wipe it off with a little bit of alcohol. And I'm not going to actually etch this one. I'm just going to sort of like pick a random one just to kind of show how I did it. So I'm going to cut a little strip here for one of these out. And this is printed on like glossy photo paper, or just glossy paper. I don't remember which one, but it's not the greatest stuff, but it works okay. So got my little strip there, and I got to make sure that I get like the edges like as kind of like as much in as I possibly can, because this strip is actually not that wide. So a little tiny bit of this might actually stick out of the side, but that's not a big deal. So yeah, I'm just going to cut a tiny little bit off like that. And I should have probably been doing this on my cutting board, but I'm not going too hard on this or anything. So I just want to kind of like score the paper there, and it breaks right off. Yeah, that's good enough right there. And maybe I'll just trim this a bit right here just so that I don't have a lot sticking out on that side. Like that. Put that side down onto the copper. So now I'm going to take this completed little sandwich here, and I'm going to put it up on this little piece of circuit board material because I don't really have anything else right now I can use here. And I'm just going to take a regular clothes iron and attach that printed toner to a piece of copper. And because this is a transparent laser transparency paper, it doesn't melt very easily. So I'm able to just kind of like run this across. I kind of do this a few times until I'm pretty confident that the toner has stuck to the copper. All right, I honestly don't know how good this is going to be, but as I said, I'm not going to actually etch this one. I'm just going to show you how I get to the next step. So then it's just a matter of soaking this in water for a bit, letting that paper soften up. And after it's been soaking for a bit, you can see that the paper, I don't know, yeah, right there, you can kind of see how it's become translucent. You can kind of see the toner underneath. So now this should peel off fairly easily and leave the artwork behind. So yeah, that looks pretty okay. Kind of like roll this off. It sticks pretty well, so I don't have to worry about being too harsh with it. And the funny thing is that this one's actually looking better than the first one I did. I didn't really intend for that to happen, but it's yeah, this is actually looking pretty good. So I guess if I need to recreate this, if I screw the other one up, this one, then I have a backup now. And so that's what that looks like now. Unfortunately, it looks like I didn't get very good sticking right there in that part. It kind of like rubbed off a little bit and a little bit right there. But what I did on the original one is in some spots where it looked like the toner was like a little bit porous, I used a really fine tip Sharpie and I kind of went around and tapped to like kind of fill in some of those areas. So that helped. And one thing you might notice here is how these corners, like right there, the corner right there of that pad, they kind of attach to that center trace between those two pads. A little bit right there, a little bit right there. I thought, well, that's no big deal because I can actually score that when I attach it to the board. But in reality, that actually ended up becoming kind of a benefit on this one here because now this entire thing kind of is kind of like a lead frame almost because they're attached at that spot there. This whole entire thing is it's kind of peeling off right there as you can see, but the whole entire thing is attached together, so it's going to be easy to like maneuver this on the board without having to like deal with individual tiny little pieces. So I think that's going to help. And then once this thing's adhered to the board, then I can go through and like cut those off and make sure that, you know, I'm not getting any continuity between the pads. So the next thing to do now is to attach this to the board. And I had to think about how I'm going to do that as well. And what I think I'm going to do actually is start by getting rid of the original pads. And I think that'll leave these sort of like small cavities where the original pads were like open so that the other ones will like kind of like fall into place there and stick. I think what I'm going to do is I'm going to use some epoxy to try to attach them to the surface here. And this is actually a little more difficult than I thought it was going to be. I thought I was going to be able to maybe just like get underneath and like peel it off, especially since the corrosion there had kind of already like attacked this some. So maybe not. Maybe what I'll do instead is I'll just leave this in place and I'll put like a little bit of like epoxy on each one of these pads and then take the new pads, place them on top, and you can see that this is like really hard to see there because it's I think some of the etching liquid kind of got underneath and made this look kind of nasty. But my original plan was to like stick this entire thing down and then peel off the transparency paper. But since that doesn't look like it's going to work too well, I think I'm just going to remove them from the transparency paper, just peel it off since it's already peeling off to begin with, and just manually stick them down onto these new pads. I do have to scrape some of the solder mask and some of this like silk screening here so that I can solder those little nubs to be able to make contact with those traces. And I actually have a tool that I'm going to use for that, so I guess I should do that now, actually. So what I'm going to use is this little grinding pen. I actually bought this from Northridge Fix, and it's actually a pretty nice little pen. It's got three different speed settings, and the cool thing is that it tries to maintain like a constant speed even as you put a load on it. And you can kind of see how, as I kind of squeeze the collet here, it the level there goes up. So it tries to maintain a constant speed no matter how much pressure you put down on whatever you're grinding. So that's really helpful, because I tried one before that was basically just like a battery and an on switch. And as you load the motor down, there's no compensation for it. So it'll slow down, and then, you basically don't do anything. So I'm going to use this, and I'll grind away at these pads, and I'll show this up here up close. So I need to attach one of the little nubs to like this area here. And because you can kind of keep like constant speed on this, you can also sort of keep like a good control over how much you grind. So I think that should be good enough for that. Yeah, that looks really good. And the other place I wanted to grind away at was like this area right here. All right, let's see how this is going to fit down here. And yeah, that looks like it's going to fit pretty well. I could line it up. So like right thereabouts. Yeah, I think maybe I'll grind a little tiny bit more up here, although I could solder to like right there. So yeah, maybe just a tiny bit more. And then this one here looks like it's going to be really good. Actually, maybe just a tiny. Actually, I could just trim the actual little bit of lead that goes out to there. So that's not a big deal. I'll probably just leave that as is. I'll just remove a little more material from right there. Now there is still a little tiny bit of corrosion there. So what I'm going to do is I'm going to put this little swab with some vinegar on it and let it kind of like soak in there. You can kind of see how stuff is bubbling, meaning that there's still like alkaline solution there. See little tiny bubbles right there off to the right. All right, and I think that's where we're going to leave that. So I'm going to gently try to peel these off. Yeah, maybe if I kind of like curve it like this. There we go. All right, here's the new pads. Let's see how well they fit. It looks like I might have lost some of the plating on that, which is kind of unfortunate, but I mean, this is all kind of experimental, so yeah, look at that. That's gonna, yeah, that should totally work. All right, I think it's time for epoxy. So move this out of the way. Now, my initial thought was to use like JB Weld for these pads, because I thought, well, it's going to be more like heat resistant. But then I remembered I'm not soldering to these pads, so I'm going to use this 5-minute epoxy stuff. The only places where I actually need to solder is to the two little nubs that are going to stick out right there, and those are, they're not going to be transferring too much heat to the pads, and it should be a fairly quick process. So I'm going to mix this stuff up, and then I'll apply like small little dots to like each pad where it's going to go there. And I'm going to also apply some like kind of like to the outside where some of those traces need to stick to the board. But I think this will work just fine. We'll see. All right, I've got the epoxy mixed up, and I'm going to try to be really quick about this, because even though it says 5 minutes, it really doesn't feel like it's 5 minutes when you're trying to like hurry up and do this sort of thing. So I'm going to put just a tiny little bit, a little drop of epoxy right there on all those pads, and a little bit over here around the edge. Geez, you can't even see that. Or is it not sticking? No, it's there. You just can't see it. All right, we'll leave that like that. Clean off my tweezers because now I have to bring in the new pads. Okay, here goes nothing. This is a bad angle. All right, this is a little bit better. Try to bring that down, set it down right there. Sweet, that alignment looks pretty good. Okay, now I want to hold that down so that it can cure and stay as flat as possible. So what I'm going to do now is I'm going to take a little piece of Kapton tape, a little bit bigger than the actual entire surface there. I'm going to set it down, try to line it up here with the edge of the headphone jack, and let's see if I can push all that down and keep the pads there aligned. It looks like it shifted a tiny bit right there. Too much glare is hard to see, but yeah, I'm going to need to move that a little bit. Actually, I should have put those pads on the tape to begin with, I think. Okay, that glare is definitely not helping. I'm not going to worry too much about that. That's not too bad. I do want to make sure that they are sitting like as flat as possible, though, so I'm going to just rub this back and forth there, try to make the epoxy kind of like squish out. Guess that might have been a little too much epoxy, but that's okay. I can remove the excess. I can't add any more after the fact. All right, just going to let that sit undisturbed for a bit, and we'll be back. This has been sitting here for a few minutes now, and before it solidifies too much, I am going to remove the Kapton tape, and I'm going to try to scrape away as much of the epoxy as I can. So I just need to find some good spot to grab it from here, and hopefully we don't peel off the copper. Nope, looks like it's pretty good there, actually. Yeah, there we go. And it does not look as pretty as what I had envisioned, but I think it's going to work just fine. So I'm going to use this really wide blade here and try to like scrape away. Okay, I'm going to have to try to grab this with some tweezers though. Stuff is really sticky before it fully cures. It's really hard to see, but there is stuff right there. You'll be able to see it once it actually goes up. Yeah, right there like that. Not putting like a ton of pressure down because I don't want to scrape into the existing silk screen and solder mask. So I'm just being very gentle about how much I'm scraping. And actually what I think I'll do before this hardens too much is I'll actually lift these up just a tiny little bit so they're off the board like that. Just let it so it's peeled off, and that way I can add some solder like down to there and onto that side, and then just kind of like tack it down. So I'll do the same over here. Get in here. Oh man, I left way more than I needed, but that should be fine. So yeah, I can solder down into there. I'll probably end up trimming this one just a little bit. This has been sitting overnight now, and this is where we are. It's not looking as pretty as I kind of had envisioned in my head, but I think we can clean it up a little bit after everything's all said and done. It'll probably look a little better. First of all, you can kind of see right here how the epoxy has kind of like coated the surface of the pads, but I can kind of go through with a blade right here, like kind of gently, and it does come off. So we can get these all cleaned up, and I want to get these little nubs here like soldered down. I do need to clean off some of the epoxy off of the solder or the copper traces because it did coat them just a tiny bit. You can see right there that I'm scraping some of it off. So I'm going to get these all cleaned up first by trying to remove as much of that epoxy off the surface as I can, and then I will try to solder them down. Okay, here's what I'm going to try doing. First of all, I'm going to add some solder to the traces on the board. And I'm using a very tiny soldering tip and very thin solder. And need to try to keep this board steady. There we go. Okay, got a coating on there. And then I'm going to coat this one. And then after that, I'm going to apply some flux, and I'll try to use the soldering iron to bring down the pieces of copper to adhere to the solder on the board. And there we go. Let's put some flux right there, right here, and that should be more than enough. First of all, I'm going to try to get this aligned right there. That way I can just push down on it with the soldering iron. I'll do the same over here, except like I said, this one's a lot longer than it needs to be. There we go. Let's get rid of that. Okay, here goes. It's going to stick. Oh yeah. Cool. All right, now this side. Okay, and even though there isn't really much, I'm going to try to remove some of the excess off the top of these, just so that they are as flat as possible. Okay, clean this up a little. Looking good so far. And we can check continuity between where we just soldered, and there's a few vias here on the board where these traces go to. So one of them is right here, and that has continuity. And then from here, even though these are all basically attached together at this point, but it did go to right here, I think it was. No, it's not that one. Oh, yeah, it is that one. Okay, so yeah, it did solder down properly. So now we just gotta clean them up, pretty them up a little bit, and that should be done. So first of all, I'm just gonna try to kind of like scrub the top of these with this blade without trying to avoid like scoring the copper too much. It's just going to be for the next step that I'm going to try to take here to try to loosen up as much of this as possible. And unfortunately, it looks like that tin coating on this copper really is not that thick. I guess it really only coats like the surface. It doesn't keep accumulating on the copper. That's what I thought was going to happen if I let it sit there for a while, but looks like that doesn't really happen. So I think I need to use more of an electrochemical process in order to coat these a little thicker. Oh no, that one's not sticking down very well. I wonder if the heat made it peel off a little bit. Okay, before I continue, I'm going to see if maybe applying a little bit of cyanoacrylate glue or super glue right here to the corner, it'll like flow underneath that pad, maybe make it stick a little harder, because I can't really do epoxy anymore. This is a little too done already. Lift up a little bit, have it flow down there. Yeah, you can see how it kind of went underneath. Try to flatten it back down. I'm going to make the glue kind of go this way and coat this over here instead. All right, that should do it for that. Doesn't feel loose anymore. All right, now that I got those mostly cleaned up, as well as I think I'm going to be able to get them, I'm going to use this fiberglass brush to try to polish them up a little bit. So hopefully it's not too harsh that it's going to try to pull those pads off the board there. I'm just going to use this to brighten them up a little bit. Okay, I think that's about as clean as I'm going to be able to get those. And under magnification, they look hideous. With the naked eye, it doesn't look too bad. But I am going to clean all this up around here. And then we'll go to the next step. And looks like that tin plating on the copper pads here was like completely pointless. I mean, they're back to bare copper for the most part. So, oh well, like I said, this is all pretty much experimental. I've never really tried doing anything like this before, so I think with a little bit of refinement to the technique, this could definitely look a lot better. Okay, so now I want to try separating all of these pads where they are touching these sort of like little center connections between like diagonal pads right there. I need to cut that one. Oh no, that one still has. Jeez, that one's still no bueno. Anyways, yeah, I want to trim the corners of these like that and like that to get them separated from those diagonal traces. And since this stuff is really, really thin, it's really easy to cut through. And the last one. When I put pressure down on this, it kind of lifts the corner just a little bit where I score it right there. So I'm going to try to flatten those back out just a tad. All right, there we go. I think I'm just going to leave, unfortunately, I'm just going to have to leave this one kind of as is. I mean, the pressure is going to go down, and there's still some alcohol underneath that. uh, when you push the button, I mean, it's just pushing down on it, and it does appear to be very well adhered through these other spots, and now over here where I put the super glue. So, I mean, it's probably not going to go anywhere. I don't really like it, but without having to pull that like off and try to like re-adhere it, I'm just going to leave it. Okay, I'm going to wipe this area off with alcohol once more. Let that dry for a sec. All right, you can see here I put another layer of Kapton tape over the pads and the entire thing. I'm going to try to cut a little rectangle around just the actual button pads. And I'm really not pushing down very hard on it. I'm just pushing down enough to feel like it goes through the tape. And then just pulling along. Okay, hopefully that leaves a little rectangle just over those pads. Let's see what happens when I pull this off. I guess I can try to use the very edge of this, or the very tip of this blade here to kind of hold it in the corners. I'm going to use some tweezers to pull up on it. Sweet, that worked perfect. Okay. So now the reason I put that Kapton tape over those pads is so I can apply some white paint around it with this paint marker. Man, that looks thick under magnification. Okay, and before it completely dries, I'm going to try to peel off that layer that's covering the buttons. Let's see if this will... Oh, no! It went underneath the tape. That did not stick on there very well, did it? Nope, it came in from that side. That's... Why are you being such a pain? Well, I'll leave that be. I will try to scrape it off of those pads when the paint dries. All right, so it's not that pretty, and it's a little smudgy, especially right here over on this corner. Like, this corner just hates me. It does not want to cooperate all that much, but I think that's as good as it's going to get. So now that I've got these pads exposed, I'm going to try to tin them again. But what I'm going to do this time, since I can't really like soak the board or anything, is I'm just going to dip a Q-tip into the tinning solution, and I'm just going to tap it to these pads and hope that that actually will do it. It really doesn't take a whole lot to coat them. So once that's done, then I'll get another wet Q-tip, and I'll just try to wipe them off, and I will dry them up and everything, and we'll see how that looks. All right, so the operation appears to have been a success. They are tin coated now. We can kind of see how there's a few little spots like right there in that corner. Over here, maybe there was still like a little bit of coating of like epoxy or something, so didn't quite get like underneath everything. But the majority of the exposed copper is coated. So I think I'm just going to have to leave it at that. It's definitely not as pretty as what I had envisioned in my head, as I've already mentioned. But it should be functional. This should work. By the way, the select pad, everything on it was okay. So I don't really need to do any work to that side. It was just the start that was completely destroyed. Next thing I want to do is finish cleaning up some of these vias right there. You can see that there's some green stuff in there. So, and like right there. So what I'm going to do for that is I'm just going to take cottons, or like a cotton swab, soaked in vinegar, and I'm just going to touch it to like these points where I find like little bits of corrosion, like right there. Let that soak for a bit and dissolve all that stuff, and then just like clean it back up. So should be a simple process, and I want to do that before I try to test this thing again, because if the button tests okay, I just want to like, put it back together and just leave it that way. So I will clean all these up, and then we'll test it out once again. See how they're bubbling away. So definitely still stuff in those. All right, this is it. If this works, then we are completely done. Just have to put everything back into the case. And I'm going to proceed to hit the I'm feeling lucky button, and I'm just going to put the 3 inside screws to attach the board to the front of the case. And 3, put the switch on over here. And that should be it. Here we go. Well, still turns on, so that's good. Put this up a little bit there. That's good. Oh, volume up this way. Okay. Let's see. Is the start button going to work? Haha, nice. And why is this moving by itself? Are you serious? We still have another issue? Oh my freaking. And okay, buttons A and B are not responding either. Oh man. We got more work to do. Okay, fortunately, it looks like these are going to be a lot easier to solve than the other issues. It appears to be just these buttons became victims of the corrosion. You can see right there that we have a via. This is the button to go right. So that goes to a via. And on the opposite side, we can see that these traces go off over here into like one of these little diode arrays. So if we look at the schematic, we can see that these are the buttons, and this is the D-pad, and these are the diode arrays. So what it looks like it's happening is that the microcontroller or the CPU is switching between these 2 diode arrays so that it can either get the D-pad input or it can get the button input. So I think that being broken to the D-pad selection pin or the diode array is what could be causing that problem. And we also had button problems over here. And we can see here that we've got some beefy traces going from the buttons over to these vias. But I think that the corrosion must have also damaged some, like right there, even though I tried to clean all this stuff out. But I mean, cleaning it out is not going to automatically make it make good contact. If we look at the other side, we can see how they are going to these like really, really, really thin traces. Yeah, it appears that it's just a corroded via issue for these. So I'll try to fix all these up, and then we'll see if it works. Okay, so this is what we're doing. I've stuck a thin strand of wire through every single via that goes to a button pad. And I'm going to take the grinding pen again and just kind of like grind like a small little area there. Solder the wire to that pad, trim it, and then do the same on the opposite side. And after that's all done, I'm going to make sure that I have continuity between every single button pad and the diode array on the opposite side of the board, and also to the CPU, so that if there's a break anywhere in the line, at least I can rectify it before trying this out again. So let's see how that goes. I was having some trouble figuring out where this via went. Look what it does. It comes out, it goes around this hole, and back up that way to the diode array. Okay, all the vias are done, and I have verified that I have continuity all the way from the buttons to these diode arrays and also to the CPU. So it should work now. Let's give it yet another shot. And from a far off glance, you can't even tell that I did anything there, really, because I tried to leave them as short as possible. Not even going to put the screws on this time. All right, please work. Let's see. Here we go. Okay. Start button works. There we go. Right, left. Can't really do up and down yet. Well, actually, I can do down right here. That. Or was it B? Oh, never mind. I can't do. Where do I... There's some that you can push down on. But B is working. A is working. Yeah. There's got to be a warper on here that I can go down in. I think it's due to the fact that this isn't screwed down very well. I'm having a little bit of a hard time pushing on these buttons to get them to respond, but they are working, so... Okay, so I took it back apart and I put the screws on the back of the board so that I could just see if it makes a difference with the button presses, and it sure does. So it's a lot more responsive with the screws in place because it holds the board more securely. So yeah, everything seems to be working just fine, and unfortunately in this game I don't think I can push down at all. But I mean, all the buttons seem to be working now, so I'm pretty confident that it's fine. I did try to find another Game Boy cartridge that I may have had, but I cannot for the life of me figure out. Okay, it's too hard to play. Watching the capture window there, I can't respond to the button or the what's going on the screen like in time. So you saw me there, kind of struggling to do things. I actually have to look at the screen itself. But yeah, no, I think it's gonna be fine. And finally, unless something else comes up, I think that's gonna do it for this one. So I'll just finish putting the screws back on the case, and we should be all good. Hopefully, no other unexpected or unforeseen issue comes up in the future. So, yeah, let's just put the rest of the screws on. Just gonna give the threads of these screws a little bit of a cleaning, the ones that were kind of grimy looking. They're not gonna look pretty, but I mean, that's we're gonna have to make do with that. All right, and there we go. One parts or repair Game Boy, completely repaired, I hope. So, all good. All right, well, for being such a tiny little device, that was quite the trip. Definitely a lot more work than I initially thought this was going to be. So, thank you all once again for watching, and I will see you all around the bench.